Okay, so let's start doing a few past paper questions that are related to what we have learned so far. Okay, so far we have learned about converting decimal numbers into binary and binary numbers into decimal. And we also learned how the computer works structure, the IPO cycle we learned. Okay, so over here I have got the 2019. I have collected some questions from the 2019 past papers. Okay, so over here it talks about a long distance running race uses an electronic counter that counts each competitor who finishes the race. The count is stored as a binary in a 12-bit register. So when you see 12-bit, you know that they're using 10 digits to represent the value. Sorry, 12 digits to represent the value. Okay. A denary value of the count is displayed on a screen above the finish line. The screen currently displays. So this is the denary value that is displayed on the screen. Okay. State the binary value that is currently stored to display the count shown. Okay. So they're asking us to convert this into binary, okay, and tell us what the binary value is. Okay, no big deal. Okay, so the number that we had, the number that was given to us was 39. Okay, 0039. Okay, so we have to convert 39 into binary format. Okay, so very simple. Let's move down. Let's take the number 39. Okay, let's take it in color. So if we take the number 39, that two zeros in front do not make a difference. Okay. So 39, let's start dividing by 2. Okay. So we have 39. So 39 is a big number. Let's take 3. Okay. So in 3, we have 1 and we have 1 remainder. That makes it 19. In 19, how many 2's do we have? In 19, we have 9 2's. Okay. And we have 1 remainder. Okay. So I'm reminding you again, the moment you see that this is an odd number, just keep in mind the next step is going to have 1 remainder. Okay. So over here, also you can see this is an odd number. So now itself, if you want, you can put 1 remainder. Because if it's an odd number over here, there is definitely going to be a remainder in the next step. Okay, if this is an even number, then there is not going to be a remainder. You can simply put 0 over here. Okay, right, divided by 2 in 19. In 19, how many do we have? We have 9, remainder 1. Okay, in 9, how many 2's do we have? We have 4 2's and we have 1 remainder. In 4, how many 2's do we have? We have 2 and there is no remainder. And in 2, how many 2's do we have? We have 1 and the remainder is 0. There is no remainder. Okay. So again, let's keep in mind our answer goes this way and then it goes upwards. Okay. So our answer is going to be 1 0 0 1 1. Okay. Now remember that in the question paper, they told you that it is a 12-bit register. Okay, a 12-bit register is being used. Okay, so immediately you need to put, so how many digits do we have? 1, 2, 3, 4, 5, 6. So you need to put another 6 zeros in front so that it would fit the 12-bit register. Okay, so another 6 zeros. 1, 2, 3, 4, 5, 6. Okay, so that it will fit the 12-bit register. Okay. I hope it makes sense. Okay, let's move on to the next question then. So this is done. The next question, it says more competitors cross the line and the screen now displays 350. Okay, now the screen displays 350. State the binary value that is currently stored to display the count shown. Okay, so again, this value of 350 has to be converted into binary format. Okay, so I'm sure you guys can do it on your own, but I'm also just going to do it over here and show you all. So if you take the value 350, okay, base 10 because it's a decimal number. So now 350, we need to convert it. We need to start dividing by 2. Okay, you know what I'll do? I'll do something different this time. Now, when I'm in the previous question, I used the sorry. In the previous question, I used the division method. No, that was method number 2 I taught you all. Now I'm going to use method number 1, the subtraction method. Okay, so before you use it, just to make it easy for your subtraction, get the position values in place. Then it becomes a little easier for you. So you should know the position values by now. We start from the right end. So we start with 1. Okay, initially we have 1. Okay, then from 1 it doubles, it becomes 2. Okay, not doubles, it comes to 8. It becomes times 2. We increase it times 2. Okay, so this becomes 2. Then the next position value will become 4. Then the next position value will become 8. Then the next position value will become 16. Then the next position value will become 32. Then the next position value will become 64. The next will become 128. And the next will become 256. and the next one will be 512. Okay, the next one will be 512. Okay, now remember, you are taking 350. The value you have is 350. So remember, let me just draw a line over here so that we have a separation. So if you were to take 350, 350 is closest to 256. So we put a 1 at 256 because 350 is closest to 256. I'm again reminding you all, the value, the position value that you take has to be either less than or equal to your value, which is 350. You cannot take 512 because 512 is greater. Okay. Right. Moving on to the next part, the next one. So we have 350. Next. So now what we have to do is we have to take 350 minus 256 because 256 has been taken. Okay. So 350 minus 256, if you were to take it, you would get 94. Okay. So the value that you have remaining is 94. Okay. Right. So if you were to take 94, if you look at the value 94, 94 is closest to 64. As you can see, 94 is closest to 64. Okay, so we can put a 1 at 64. Okay, so 94 minus 64. Okay, you would notice it is equal to 30. Okay, 94 minus 64 is equal to 30. So the value that is closest, okay, 30 is closest to which position value? You cannot take 32 because 32 is greater. Okay, so you'll have to take 16. So you put a 1 at 16. Okay, so now 30 minus 16. Okay, 30 minus 16 is equal to 14. Okay, okay, so 14 is closest to which position value? It is 8. So we put 1 over here. Okay, so now we have 14 minus 8. Okay, so 14 minus 8 is equal to 6. Okay, 14 minus 8 is equal to 6. 6 is closest to which position value? Yes, it is 4. So we put 1 over here. So 6 minus 4 is equal to 2. Okay, 6 minus 4 is equal to 2. So we put 1 over here. Okay, now it's completed. Now we only have blank spaces. Okay, because 2 minus 2, if you take 2 minus 2, it is equal to 0, which means at this point it was complete. Okay, at this point it was complete. You cannot go any further. Okay, so the empty boxes, places like this, okay, you will simply be putting zeros over there. Okay, so you will put a 0 over here, you will put a 0 over here, you will put a 0 over here, you will put a 0 over here. Is it clear, guys? You will simply be putting zeros over there. Okay, so your answer will finally be, this will be your answer. Okay, so your answer will be 0 1 0 1 0 1 1 1 1 0. Okay, but keep in mind, in the question paper they spoke about a 12-bit register. Okay, so how many digits do we have here? 1 2 3 4 5 6 7 8 9 10. So we have 10 digits. Simply add 2 more zeros in front and make it a 12-bit register. I mean, make it 12 bits. Okay, so it will fit the 12-bit register. That's it. Okay, so I hope you can also attempt this question on your own. Please do attempt it. Okay, right, let's see if we have another question that we can try over here. So over here at the end of the race, so let's put a tick that we have completed this. Okay, at the end of the race, the binary value stored is, so at the end of the race, this is the binary value that is received. Okay, so give the denary value that would be displayed on the screen at the end of the race. So now we have to convert from binary, we have to convert into denary, or we have to convert into decimal format. Okay, very simple. So once again, what we do is we give it position values. Okay, we give it position values. Okay, so what I would do is I would simply say this is 1, this is 2, this is 4, this is 8, this is 16, this is 32, this is 64, this is 128, this is 256. Hope you guys can see what I'm writing. This is 512, and this is 1024. Okay, so just give it its position values. Okay, you do not need to write 2 to the power of 0 is 1, 2 to the power of 1 is 2. You don't need to do that anymore. Okay, so like I've been telling you guys, you can ignore the zeros. The zeros you can simply ignore because they do not make a difference. Only focus on the ones. Okay, so if you look at the ones, if you start from the left, you have 512 plus 256 plus sorry, I have missed something. Okay, so I have missed something. So we go 1, we go 2, we go 4, we go 8, 16, 32, 64, 128, 256. So 512 is supposed to come over here. Okay, 512 comes over here. Let's erase this. 1024 comes over here. 2048 comes over here. Okay, so I missed it. Okay, so let's now start writing. We only focus on the one. So we have 1024 plus 512 plus 128 plus 64 plus 4 plus 2 plus 1. Okay, so once you add all of this will be your binary value. Okay, so if you were to add all of them, 1024 plus 512 plus 128 plus 64 plus 4 plus 2 plus 1, you would get something like 1735. Guys, I would recommend you also just check. I did do the calculator over here. I'm not sure if I missed a number or not. Okay, but basically you understood the method, right? The working is what's most important. Okay, you should be able to work it out. Okay, so I hope that makes sense to you. Okay, right. Let's move on to the next question. Let's see what else we have. So let's keep this. We haven't learned this yet. Let's move on. So over here, it's talking about hexadecimal. We haven't done hexadecimal yet. Let's move on. Okay, so let's do not necessary for us to do all three. Let's do only the second one. Okay, only the second one we are going to do. Okay, I'm just trying out random questions from the past paper. So for example, if we were to look at this, let's write this number in a much bigger way. So 0 1 1 0 1 1 0 1 1 1. Okay, so we are supposed to convert this into decimal format or denary format. Okay, so let's give it its position value. So we start with 1, then we have 2, then we have 4, then we have 8, 16, 32, then we have 64, then we have 128, then we have 256, and then we have 512. Okay, then I have told you guys, ignore the zeros. You don't need to worry about the zeros. You only need to focus on where the ones are. Okay, so very simply, you will have 256 plus 128 plus 32 plus 16 plus 4 plus 2 plus 1. Okay, so if you were to add all of this, you would get the denary value that you can put over here. Okay, right. Let's see if we can do one more question. Just one more question we'll try and do. State the hexadecimal. So we haven't done this yet. An 8-bit register contains the value. So this is the value. Convert the binary value into decimal. Okay, very, very simple. So again, give it its position values, which is 1, 2, 4, 8, 16, 32, 64. We don't need to worry about this with 0, but doesn't matter. So now we only focus on the ones. Where are the ones? Okay, so now we take 32 plus 16 plus 4. That's it. Okay, so you will have 38, 48, 52. Okay, you would have 52. Let's see if we can do one more question where we convert. Now we had done a lot of conversions from binary to decimal. Let's do one decimal to binary, and then we can go back to our lesson. Okay, decimal to binary. Okay, so that's the end of the paper. There isn't another one. I have just taken the 2019 papers only. Okay, right. So next we have to move on in our tute. The next part in our tute is where we will be converting hexadecimal numbers. Okay,